It's week 2, Geometry Kids, of distant learning. So last week we did solving right triangles. It appears that you did pretty well on that as all the assignments are coming in. Thank you for that. Today, or this week, is really kind of a continuation of what we've done on trigonometry, using ratios to find side lengths, using the inverse ratios to find angle measures. We're using that through what we call angles of elevation and depression. So really, we're going a little bit deeper this week, and it's mostly problem solving, which I know you love, is what we're going to do. So the first definitions: angle of elevation and angle of depression is formed by a horizontal line of sight. So let's pretend you're flying an airplane. You're up here, and you're in your plane, you're flying around, and you see down below the tower where you want to end up landing. So you're looking down. The angle of depression is determined by a horizontal line of sight. So if you look straight out this way, and then looking down, that's the angle. Horizontal is a key word here. That means that this line, the imaginary line that you're looking at, would be parallel to the tower guy or gal looking out this way. If these are parallel, we have all of our alternate angles, theorems, corresponding angles of congruency. They all come into play, and we also have right triangles, so we can use our trigonometric functions. So that's what we're doing this week: angles of elevation and depression, just added to our tool bag of triangular ratios. So here's the picture out of the text. The angle of elevation, again, angle of elevation in this case is the angle 1. There's the tower guy or gal looking out this way. That's the horizontal line of sight looking at the plane coming in for hopefully a safe landing. The pilot, horizontal line of sight, is looking down to make sure he sees the tower so he can have a safe landing. So that's angle 2. That's an angle of depression as he's looking down. This is an angle of elevation as she is looking up. Okay, angle of elevation is the angle formed by a horizontal line in a line of sight to a point above the line. So that's basically how you can form your triangle. So the examples this week, for my beautiful drawings. So first of all, we're classifying all the angles. Is that a bird? It's not very clear. It's in your book. So we're basically angles 3, 4, and 5. Which angles are they? Are they elevation or depression? Look at the horizontal line, and then from there, if this one's looking down, that's depression. There's the horizontal line for angle 6. It's looking up, angle of elevation. Fairly straightforward. So this is how you can use that, same as what we've done before. Here's the air traffic controller. Is at an airport. He sees a plane, or she sees a plane, at an angle of elevation of 41 degrees. Okay. Note this right here. Draw a sketch to represent the given information. Do you remember the video from Friday's recap about my brother Bill and the website he loves? Well, I was looking at that website, so we're going to take a little side. Oh no, it's not here. Pause so I can find it again. I don't want to waste your time. Let me pause for 1 second. So I got back to your Canvas page. So on Friday, when you look back and you saw these little the sign ratios that my brother found us on that cool website. So on that website, I want to show you very quickly. This is awesome. If you go to home, you can look at a lot of different things. This is I love this website. But when you get to trigonometry, solving picture word problems, the general approach. Look at the very first thing they say. This is universal. This is not just me talking. I don't want you to think that I'm making stuff up. The general approach. I love this. If a diagram is not given, create one. Draw your picture, especially when we're getting triangles and you're making up stuff. Draw the picture and then write the ratio. Okay, and then pick your tools to use that. So it's not just me. It's everybody. It's the best way to do that. So now we're going to go back to a notebook. So the draw a sketch to represent the given information. So A is the airport, P is the plane, and it looks like that. There's the airplane, there's the airport. Now if I had my horizontal line of sight, it would be looking out that way right there. Okay. this is the guy. Horizontal line of sight is here. The air traffic controller looking up, angle of elevation of 41 degrees. To find then how far away the plane is away, he can write his ratio. That's going to be opposite over adjacent. That would be the tan 41. So tan 41, and that gives you how far away it is. Again, round to the nearest foot. So that's kind of the stuff we'll be doing today. Another example is you have the picture. Now this is, so I wish we were in a classroom, because you know how, look at this. This is last year's wonderful drawing I did of this exact very same picture. Let me move so you can see it better. It's not, where's the screen to move here? There it is. There it is. Isn't that a beautiful picture of me? Anyway, this is the same kind of drawing. The tower, they had people lookout towers. Mount Pilchuck. You ever come to Mount Pilchuck? That's what that little thing was there. That little place you go to if you climb up there. It was the lookout tower. They're looking out. There's the fire. So although the line of angle of depression 7 degrees, you need to make sure that you are using this angle F is 7, because these are parallel lines. So because it's a transversal, that although is the angle of elevation, but the angle for the triangle is the one down there. Don't get confused by that. That's what the caution says right there. So you can figure out how far it is from the tower to the fire by going tan of 7, 90 over x. Use your calculator and you get 733. All right. Next example might be the one a little bit where you need a little bit of help here. So I'll show you that. Is same kind of a thing, but there are two different towers. So there's the pilot. Pilot sees tower B, tower A. So you want to figure out the difference between the two towers. What is the distance between the two towers, between A and B, which is you want to find the x value. To do that, you would find, as you go through the steps, first of all, find y. There's your triangle. It would be 2.7 over tan 58 would give you that side right there for y. And then you need to find the z for this big triangle. And that would give you 3.58. And then you would subtract the 2 to find the difference. So you have one problem today just like that. The two steps are find the y, find the big triangle, and then subtract to find the difference. Okay, so today's lesson is basically going to be using these angle of elevation and angle of depression. So again, two lessons or two assignments. The lesson part due on Wednesday, which is these 5 problems, or 6 problems, 3 through 9 on page 547. For number 9 is just like you want to look at example 4, which is this one here. Is very similar to number 9. Now this week I'm adding a little bit more. Rather than just giving me a number and self-evaluating, you are entering an answer for a problem. So in your solutions, when you correct, you'll see number 8 I am not giving you. So I want you to enter number 8 in Canvas with your self-evaluation of 4. So anyway, that's what we'll be doing this week. Nice job today. And talk to you soon. Good luck.